Welcome back, ladies and gentlemen. This is Dr. Robinson, and today we're going to talk about the systems of linear equations. So, our student outcomes that we expect the students to know that a system of linear equations, also known as simultaneous equations, is when two or more equations are involved in the same problem and work must be completed on them simultaneously. Students also learn the notation for simultaneous equations. Students compare the graphs that comprise of a system of linear equations in the context of constant rates to answer the questions about time and distance. Our vocabulary is systems of linear equations, also known as simultaneous equations, is two or more linear equations with the same variables. The solution of the system of linear equations is the ordered pair of the x and y coordinate that makes both equations true at the same time. So that's important. The x and y coordinate for both equations have to make both linear equations true. Here's something you should note. Systems of linear equations may have one solution that is, no solution, or infinitely many solutions. If it has one unique solution, if you look down here at our first graph, these lines, the blue line and the green line, they intersect at this point, 3, 2. So that's one point that they have in common. The green line and the blue line have that one point in common. That's why they intersect at that point, 3, 2. So that would be their point of intersection or their solution set. Here's our second graph where we have two lines that are parallel. Notice they do not intersect. There is no solution because they never ever will touch. They'll just be parallel to each other, so they never intersect. So there is no solution. And this last graph over here, we have an infinitely many solutions because the lines coincide. In other words, we have a blue line, which I'll remove here, which is on top of the green line. So the lines are the same, and so every point is equal to each other, so the line goes on forever. So the line has infinitely many coordinates, so there are infinitely many solutions to the blue line as well as the green line, so it's the same line as well. So let's get on with it and solve and graph and check our two equations. Here we have two equations, 2x plus y equal 8, and we have y equal 2x plus 2. Now, we need our graphing calculator to graph, but our first equation here, we have 2x on the left side, and we really need to get that to the opposite side. So what we need to do is type minus 2x on both sides so we can get this to cancel this out on this side. Let's clone it. And it'll move over to this side. So the 2x's will cancel out, and we'll have the y equal to the 8 minus 2x, or if you want, you can put the 2x and the minus 2x in front, plus 8. So that's a little bit better. So now you can use your graphing calculator to plug these values in your calculator. So let's type them in our calculator. Negative 2x plus 8. There is our first equation. Now let's type in our second equation. X plus 2. And there is our second equation. And now, let's see. Let's graph that out. So let's zoom 6. And we're going to see our blue line, our first equation, the negative slope line, negative 2x plus 8. And there's our second equation, the x plus 2. So we're interested in where do they cross or where do they intersect? And they intersect right there. So we need to find that point of intersection. If you remember in class, we have to go to our second calc menu and go down to the intersect, which is number 5. And now we got to press our enter 3 times. 1, 2, 3. And there gives us the point of intersection for this, which the point of intersection is 2 for x and 4 for y. So that would be the value that intersects and answers both of these equations at the same time. So that's using our graphing calculator to calculate the point of intersection and answers both of these equations. So if I replace x with 2 and y with 4, in both of these equations, they would answer the same thing. So let's go to check your understanding. Hopefully you understood what I said. If you did not, please write down your questions and rewind the video and watch it again if you have to, and be ready to answer some questions tomorrow. But let's go into an application of where this really can bring it home for us. Here we have a Peekskill Herald publishing company that publishes a monthly newsletter. They have expenses of 90 cents for printing and mailing each copy. So each copy is 90 cents. And there's an additional $600 for the research and writing that they have to pay. So these are their expenses, I notice. The price of the newsletter is $1.50 per copy. So if they sell it, they're going to get $1.50 for each copy that they sell. How many copies of the newsletter must they sell to break even? So when does the cost equal the expenses and profit? So let's set up our representation. So let x equal the number of newspapers and y represent the income or expense. So we have two equations that we're having here. We have one for expenses, where it's 90 cents times the number of copies, which is X for the newspapers, plus the $600 they have to pay for the research and writing, and that'll equal the dollars of expenses, Y. The income would be selling the newspapers at $1.50 for each copy. So no matter how many copies they sell, they're going to get $1.50 from each copy. So X, we said, let that represent the number of newspapers that they generate or sell, and Y would be the dollars of income that they get from selling. So we have two equations in the form of Y equal. So let's get our graphing calculator. And move that over here and get them in here. So let's clear out these old equations and get the typing. So 90 cents, 0.9 x plus $600 are the expenses. So that's our expense equation, and $1.50 per newspaper times x will be the equation for the income. Let's zoom 6. And hopefully it'll come. I see one equation coming up. There's one line. And hopefully another one will come soon. Where's the other equation? This sounds like an emergency to me. So let's press that zoom emergency button. So zoom 0, zoom fit. that will get it a little bit better for us. It's still not good. So we have to go into the window and play around with this. So let's look at what it's given us. We have 600, which is the Y maximum value. So maybe we should change that up, because if it's the expenses are $600, maybe we should expand that to say maybe a couple $1,000, say 2,000. And let's put down, say, 100 would be the minimum amount of money that we would get. And let's count by, say, 50s. And let's go to our X newspapers. The maximum amount of newspapers we would sell is 10. Well, I think we need to sell a lot more newspapers than 10. So let's say about 2,000 newspapers. And the minimum, well, we couldn't sell negative newspapers. So let's say a minimum of 100 newspapers. So these are just rough estimates. Let's graph this. Let's see. Oh, let's change the scale of this. Make that count by 50s also. I see one line, and there's another line. Much better. So now we have to figure out what is that point of intersection for us selling these newspapers. So let's go to our second calc. Again, number 5 for intersect. And notice it's close to it, so let's press enter 3 times. 1, 2, 3. And the point of intersection is 1,1500. So that means we need to sell X, which is 1,000 newspapers, and Y would be $1,500 would be our income. So the break-even point we need to sell is 1,000 copies of the newspapers in order to make $1,500, and that would only make us break even in our selling of the Peekskill Herald. So we would just be at a break-even point, so our expenses would match our income. So we really wouldn't gain any money, so we'd have to sell more than $1,000, 1,000 copies to get some money out of our investment of making all these papers. So this is how systems of equations really come into play when we're dealing with real life situations. So I hope you got something out of this. So check your understanding. If you have questions, rewatch the video. If you have questions, write them down, bring them in tomorrow. I'll be glad to answer them. If you're still uncertain, rewatch the video and talk to me in the morning. So here's a question for you. Try it on your own. See if you can get it. Solve and graph. Remember, use your graphing calculators. First question, I notice you need to set that in the form of y equals, so keep that in mind. See what it looks like. Get y by itself and solve using a graphing calculator for that point x and y, which are the same in both situations. So, this is Dr. Robinson. I hope you got something out of the video, and tomorrow we'll try to answer some more of these questions. All right, see you soon. Bye.